Okay, in this screencast, we get serious about our look at differential equations by solving separable differential equations. Separable differential equations are all differential equations of the form dy dx is some function of y times some other function of x. There's a function of y times a function of x. These are called separable. They're called separable because we can bring the f of y to this side, and we can bring the dx to this side and rewrite as 1 over f of y dy is g of x dx. Now, it's not as simple as the algebra would indicate, but that is roughly how the process works. This differential equation is the same as this differential equation, and then we just take antiderivatives on both sides. The moving of the f of y to this side and the dx to that side is called the separation. We separate the y variables from the x. We separate the terms with y in them from the terms with x in them. And then we solve by anti-differentiating. So I will illustrate with this example. Let's solve for y. Dy dx is xy cubed with y equal to 1 when x is 1. This is a separable differential equation. There's a y part and there's an x part. They are multiplied together, so we can move the blocks around, so to speak. We can bring the y cubed over to this side and have this equation, which we can then integrate. So that's the key. If you can see that, you're in great shape because everything else is stuff we've already done. We recognize that there's a function of y and a function of x. They're multiplied together. And so we can bring the function of y to the other side. We can have dx come to the right side. If you can see how we get from here to here, everything else is Calc 1. So what happens here? This is y to the negative 3. The antiderivative of y to the negative 3 is y to the negative 2 over negative 2. The antiderivative of x is 1/2 x squared. This has a constant. This has a constant. One constant is all you need. And so now it's time to solve for y. We want to solve for y. So let's see. Let's get y by itself. We'll multiply through by negative 2. That's fine. What is this? This is 1 over y squared, right? And so we can take reciprocals and be fine, right? If two things are equal, their reciprocals are equal. And so y is the square root of 1 over negative x squared minus 2c. How do we know if it's the positive square root or the negative square root? Well, we look here. That's a positive 1, so that's a positive square root. Now, what do we have to find out? We've got to find c. But we know that the curve passes through 1, 1. So the y value is 1 when the x value is 1. And we do a little bit of algebra here to figure out that c is negative 1. And once c is negative 1, that tells us that y is the square root of 1 over negative x squared plus 2. And that is the particular solution to the differential equation that passes through the point 1, 1. If it had passed through other points, we'd have made different substitutions, gotten different values of c, gotten different solutions. So the process is the same every time. We separate, moving the y stuff to one side and the x stuff to the other side. We integrate, and then we solve. If you can do that, you're in really, really good shape. I will do a second screencast that has more examples for people who need more examples. If this is good enough for you, then wonderful. See you soon.